Hi everyone and welcome. In today's session, we are going to talk about UHT solutions using tubular technology. This webinar is part of a series of technical sessions we've been running over the past few months, where we explore key technologies and innovations from SPX FLOW. Before we get into the technical content, I'd like to start with a brief introduction about myself, and thanks again for joining. So, as I mentioned, the presentation would be about the SPX FLOW UHT tubular technology. You can leave your questions in the chat, and I will answer at the end during the Q&A session. Just a quick introduction about myself. My name is Serafin Garcia. I work as the technical sales manager for UHT systems and script surface heat exchangers. And I'm the product manager for tubular heat exchangers for food applications. And I will be your technical host for this webinar today. My area of responsibility is global. And I help stakeholders like yourself with a variety of thermal applications, including UHT systems, among others. Within that topic, we will discuss the best ways to save energy and water and try to optimize as much as possible the efficiency of your systems. A few housekeeping notes before we get started. As an audience member, you will not have audio or video capability. So please use the Q&A feature to submit any questions throughout the presentation. And I will try to answer as many as I can at the end. If we don't have the time to answer all of your questions, my contact information could be provided during the Q&A session during the last 10 minutes or so, so you can catch my information details. So once again, thank you for joining today. And be ready because we will be discussing sustainable UHT solutions, specifically on the tubular technology. This is the agenda for this session. We will briefly talk about SPX FLOW. Then we will go deeper into applications. We will highlight our systems and solutions. We'll go deeper into the tubular options. And then we will finalize the presentation with pilot plans and service support. So SPX FLOW is a leading provider of highly engineered equipment. And we also do process solutions. Within SPX FLOW, we include more than 14 brands and around 106,000 manufactured products and spanning numerous industries. Our team is committed to sustainable solutions that positively impact our communities. We've recently shared our impact report, which, of course, you are welcome to view. And that one details some of our accomplishments. In fact, roughly of around 50% of our more than 400 patents encompass sustainable and clean technologies. My team could be putting the hyperlink in the chat if you're curious about it. Right, so this timeline shows over 130 years of innovation in heat treatment, from early pasteurization to today's most advanced UHT systems. But I would say that one milestone stands out. And that is in 1949, the birth of the tubular UHT systems. It marked a breakthrough for processing complex and viscous products. And even today, tubular technology remains as one of the most robust and flexible UHT technologies available for applications containing particles. That is the biggest strength of the technology. So in this webinar, we'll try to focus on how modern tubular systems, especially modular solutions, could help you to reduce OPEX, to improve the quality of your products, and also get you to the market in a faster way. UHT solutions based on tubular heat exchangers have become, in many countries, the preferred choice because we have to process large volumes of many times commodity products, and those have to be processed as cost effectively as possible. So in the next slides, we will see a number of different applications that we have divided in 4 categories. In the first one that we can see in this slide, we'll start with fluids without particles. Then we would also highlight fluids with flexible particles. The third category is fluids with unbending particles, where the particle integrity is not important. And finally, fluids with unbending particles, where the particle integrity is important. On top of that, for each category, we have classified all of those applications depending on the viscosity level, and that is lower, medium, and high viscosity. In this first category, we are looking at products like milk, tea, clear juices, or isotonic drinks, for example. So at a first glance, you might be questioning yourselves why a tubular system would make sense in this type of applications, where maybe a plate exchanger could be like a better solution. And some of the reasons are clear, because the tubular technology can extend the production running times. It could also help you to increase operational flexibility. And it is often perceived by many customers as a more robust and durable than plate heat exchanger solutions, especially when long-term reliability is a key concern. So in this second category, we can find applications like pulpy fruits and vegetables with varying viscosities. We can include as well thick sauces and fruit purees. So these type of products are typically more demanding to process, and that is why here the tubular technology is really showing its strength. In the third category, we've got fluids with non-deformable particles, where maintaining particle integrity is not critical. We find applications such as crushed tomatoes, soups, and fruit mash. And finally, the last category, the fourth category, where we have fluids with rigid particles, where the particle integrity is important. So that could include applications like soups containing particles, where the customer is particularly interested in providing some sort of homemade appearance, sauces with visible particles. Could be also yogurts containing fruit pieces. So all of those applications, we want to preserve the particle structure, the particle integrity, because that is essential for both the product quality and also for the customer perception. And within our portfolio, we've got the right solutions to achieve that. Now we move into our UHT solutions. So within the UHT processing, we can differentiate between direct UHT and indirect UHT. In the direct UHT, we have an actual mix between the steam and the product, and we can distinguish between infusion and injection. In the infusion system, it is the product going into the steam, whilst in the injection system, it is the steam going into the product. In the indirect UHT system, there is no mix between the steam and the product, and the heat is transferred from one fluid to another across a thermally conducting barrier, that is the metal wall in a plate heat exchanger, in a tubular heat exchanger, or in a scrape surface heat exchanger. In the next block, we move into UHT tubular solutions. That would be the ideal technology for beverages containing pulp, fibers, or with a low to medium viscosity. Our UHT systems are designed as a modular solution with a strong focus on maximizing energy efficiency. So that means having a low OPEX, while at the same time maintaining the flexibility to handle different products and also adapting to different production needs. Obviously, apart from our standard solutions, we can fully customize different systems so we can adapt to our customer needs. The tubular systems are typically used within sectors like dairy, food, nutritional drinks, on low to medium viscosity applications where the product contains fibers and particles. I would say it is a quite common technology in many countries where you have to process large volumes of commodity products. In some countries, it could be like white milks. And we have to run it at the lowest possible cost. And therefore, the technology of the tubular comes very handy to achieve that. Regarding different flow rates, we can go from as little as 500 liters, 1,000 liters, up to 40,000 liters, or even more, as we have in our portfolio really large models adapting to huge flow rates. And when we are developing our systems, there are like, in reality, many different tubular models and options that we can take from double tube to triple tube, quadruple tube, as well as the multi-tube that obviously is the most popular and the most sold type of tubular heat exchanger. All right, so on this slide, we can see a generic schematic of a tubular UHT system. So we could take, for example, a standard milk process. So the milk would be entering the system in the ballast tank, typically at a temperature of around 5 degrees. From there, it could be pumped into the first section of tubulars, where the milk would begin to warm up. Before going into the homogenizer, that would be the next step, we could actually have the option of including a degasser or deaerator. And that is actually important, both for preserving the sensory quality of our product and also for protecting downstream equipment from obviously the damage that could cause by having air bubbles in the product. Next, the product could pass through the non-aseptic homogenizer as we are working upstream. That would usually happen at around temperatures of 65 to 75 degrees. From here, the milk could continue its journey through another heating phase and could enter what we call the stabilization holding cell. And here is where the protein denaturation would be taking place. That is a critical step in milk processing because obviously there would be fouling, and we prefer that fouling to happen in the protein stabilization cell rather than in our tubular heat exchanger. That would be typically happening between 85 and 95 degrees. After the stabilization holding cell, the product would return to another set of tubulars where it could be heated up to the UHT sterilization temperature. That could be around 145, 147 degrees. That would depend on the application. And after that, we would go into the main holding cell, where the milk could be held for approximately 3 to 5 seconds, depending on the recipe and the product. Once again, but just to give you an idea of the typical time in the main holding cell. Following the sterilization, obviously we have to start cooling down the product to avoid any contamination. The final section of the tubular heat exchanger is typically dedicated to bringing the product down to the target temperature. That could be 20, 25 degrees. That could be depending, obviously, on the application and the product. And after the final cooling, the product could be sent either to the aseptic filling machine if the filling machine is ready to work, or we could also aseptically store the product in an aseptic tank. All right. As we are showing on this slide, the system actually has a closed water loop that you can see in blue color. So that means that the same water that we are using for heating could be used for cooling. So that is a perfect way to improve the energy recovery and the energy efficiency of the total system. So depending on the regeneration efficiency or the regeneration rate that the customer is aiming for, we can design the system in multiple ways. Typically, we can achieve regeneration efficiencies above 80%. That is quite usual. And with more advanced designs, we can achieve even higher values in the range of between 85 and 87% or even higher. In this slide, we are looking at another generic schematic of another tubular UHT system. But in this time, we can see a notable difference because we've got two closed water loops instead of just one. And obviously, this configuration is also entirely possible and can bring important benefits to the customer, depending on the process designs and the operational goals of that specific customer. By splitting the system into loops, we can better manage temperature gradients, and we can also reduce energy losses. For example, one loop could be dedicated exclusively to heating. So we could be running at higher temperatures, and in that way, we would try to optimize as much as possible the sterilization section. Other loop could be focused, for example, on the cooling or trying to maximize the regeneration efficiency with lower temperatures, set points. That would be, the ideal for recovering heat from the product in a more efficient way. So, by having this separation, that would allow us to have an improved energy efficiency because each water loop would be probably operating closer to the ideal temperature range. We can have a greater process stability, most likely, and that would be even more evident in higher throughput lines, where having a thermal consistency is paramount. We have also faster response times when there are changes in the production flow, or if we are doing any changes in the recipe. And also, in some cases, it can also protect the equipment in a better way, because we could potentially avoid overheating in certain steps in the process. So even though obviously it could add some complexity in terms of the overall design and the control philosophy of the system, a dual closed water loop system could be a smarter solution when there are customers aiming for maximizing the thermal efficiency and also having more operational flexibility dealing with different products. Let me quickly walk you through the key benefits of our tubular UHT solutions. So firstly, the system is designed for longer production uptime. That is critical. We know that that is quite important for our customers. And we're able to achieve that thanks to the actual thermal calculation, the way that we are doing the design, how we are calculating the velocities of the product within the inner tubes, and the way that we're also doing effective CAP cycles. At the same time, we are trying to cut down on energy, water, and the chemical consumption. So all of those benefits, when we are doing CAP, obviously would translate into direct cost saving for our customers. Secondly, we like to focus quite a lot on innovation through strategic partnership. So that means that we don't just sell the equipment. We like to develop tailored process solution with our customers, because at the end of the day, we want to help them bring differentiated products to the market, and in that way we can help them to boost their competitiveness. And thirdly, when it comes to handle difficult products, it could be viscous products, it could be protein-rich liquids. Our systems could ensure gentle and uniform heating, and in that way we can help you to maintain a consistent texture on the product, and also having consistency on the shelf life across the different batches that you are running. Another key advantage is like nutritional and sensory preservation. We work hard trying to optimize the UHT profile temperatures. So those are specifically developed to reduce heat-related flavors and nutritional loss. And finally, I would like to highlight how important for us is food safety and compliance. That is at the core of our design for sure, and our systems can be certified with 3A, FDA, and EU hygiene standards. So in that way, we can also guarantee a robust construction, and we can also guarantee that our system would be designed in a way that we can minimize as much as possible contamination risk during the actual processing of your product. So regarding features and benefits, firstly, we like to ensure maximum energy recovery and cost efficiency. We understand that those topics are so important for our customers. So we want to achieve higher thermal efficiency, and by the integration of those heat recovery loops, we can help to reduce utility consumption and those utility costs in a very significant way. Secondly, the system could be delivered as a pre-assembled factory-tested skid. That means that we would be delivering a plug-and-play installation. And then also in terms of flexibility, we can offer different modular flow rates. Those can go from around 6,000 liters up to 26,000 liters an hour. And the designs could be fully scalable. So the actual benefit is that you can benefit from our standard solutions, or if our standard solutions are not able to provide a good solution to you, we are also able to customize to whatever needs you might have. The entire UHT process could be fully automated. There will be PLC controls, and we would have integrated CAP in order to have an efficient cleaning and a consistent product quality. And all of that could be monitored in real time. Now, obviously, beyond the system itself, we would be happy to support our customers globally, because we can prepare tailored service agreements with our colleagues from the service department. We can also offer genuine spare parts during the complete life cycle of the machinery. And you could also benefit from like 24/7 aftermarket support from SPX FLOW experts that you can find globally. We can also highlight our global innovation network. So we have a series of different research and development centers. We have centers in Denmark, Dubai, China. Those three specifically for UHT applications. They are quite strong. We have pilot UHT plants, so we can support our customers with product development and with process validation. And finally, what truly sets SPX FLOW apart, I would say, is our collaborative approach. We like to work closely with our partners, with our customers, because we want to develop with them tailored solutions. If we cannot achieve a real solution, a proper solution with our modular standard tubulars, because at the end of the day, we want to help them launch high-value products to the market. In this slide, we can highlight three core strengths in our UHT tubular systems. We start with the production capacity. So it is built to handle high-pressure UHT applications that could be for viscous products. We can do that with our modular tubes, or we can really customize with new tubular solutions. We can really make it scalable solutions because we can fit into different production needs. That means that at the end of the day, we want to sell solutions that are flexible enough to cope with different flow rates and different products. In terms of like food safety, we offer precise F0 value control for effective spore kill, and that is actually based on proven designs experience that we have for the latest 50, 60 years of successes selling tubular UHT installations. And then product quality, obviously the system would allow for a gentle treatment of products containing fibers and particles, which is obviously where the tubular technology is the best solution. We continue now with some of the main benefits of our tubular UHT heat exchangers. We can highlight the energy efficiency because the system would use just a small amount of steam per kilogram of product, and that would help you to get down on utility cost, and obviously to reduce the total cost of ownership, which is the combination of CapEx and OPEX. Second, production uptime. In some scenarios, our technology can run up to more than 30 hours continuously on high quality milk. That is impressive. But we have even achieved more hours on clear juices. We're able to provide fast CAP cycles, and in that way extend the cleaning intervals. Third, I would say the ease of installation and the usage. As we mentioned before, our aim is to offer like a plug and play type of skid that would be pre-assembled and factory tested. You would have F0 value control, and depending on the system, it would have like a really high regeneration efficiency. In many systems, we have designed over 85% plus as regeneration rate. And finally, maintenance and scalability. Thanks to the modular design, maintenance is simple. Spare parts would be quite easy to access, and capacity can be scaled without a major CapEx investment. Here we are highlighting our NAC system, that would be the non-aseptic cooling system, which is recovering energy during the cooling and would help you to cut utility usage by around 67%, during the sterilization phase. Just to give you a reference, for a 40,000 liters an hour line, that can mean a savings of around 563 kilowatts. It could also help you to lower the cooling tower load, and in that way we can reduce the cost during the pre-sterilization phase. Here we've got what we call the hibernation mode. So basically, it could be activated during the idle water recirculation. That means that once that we have done the CIP and the sterilization and we have the system under regime, it will cut steam, the cooling load by around 50%, and also it would reduce the ice water usage by around 95%. So, after about around 30 minutes, the system would automatically enter in this low energy mode, and it could help our customers, to save on the utility between those production runs. Then we move into the tubular options. So here we present our APB Paratube series. That is the brand name for our tubular heat exchangers. That is the legacy name for our portfolio name. And we're able to offer flexible configuration. We've got multi-tube, double tube, triple tube, and we have the quadruple tube, also including the quadruple triple tube. So we can provide many different alternatives. We can go for smooth pipes. We can go for corrugated pipes. We can actually play with the corrugation of the pipe. So that means the pitch and the depth. And just to highlight as well, how service-friendly our designs, our tubular heat exchangers are. They could come with detachable components, in order to have like fast inspection and cleaning, especially if you want to do like for whatever reason, like a manual cleaning. And also for harsher applications, we could go for a fully welded solution in our multi-tubes and in our double tubes models. Now, I will try to highlight some of the benefits in every single one of what we have in our portfolio. So we start here with the multi-tube. The multi-tube, at the end of the day, is the most popular and widely sold type of tubular heat exchanger, mainly because it offers the largest heat transfer area among all of the configurations. As we mentioned before, we can offer it in both smooth and corrugated designs, depending on the product and the process requirements. Even for the same product in just a UHT sterilization system, we could opt to have tubulars in a smooth configuration and others in corrugated, depending on the step of the process. In terms of the tube sheet design, we can actually provide two options. We can go for the flat tube sheet, which is ideal when there are no particles or fibers in the product. But also we can go for the conical tube sheet, which that could be especially recommended for fibrous and particulate products, because it would improve the flow distribution. It could help particles, to enter into the inner tubes in a more easy way, and it will potentially reduce the risk of maldistribution and having blockages in the actual tube sheet. Then we have the double tube. That basically consists of two concentric pipes. This configuration is typically used for applications where you've got larger particles. It would provide a wide product channel that could help you to minimize pressure drop and also any blockage risks. However, it is also, the least efficient in terms of heat transfer surface area if you compare it with other solutions, especially if you compare it to the multi-tube, as we mentioned before, because obviously it is the one having the less total heat exchange area. So even though it's not the most efficient thermally, it is the right choice when product integrity and gentle handling are the priority. Now we move on the triple tube heat exchanger, and as the name suggests, it's made of 3 concentric pipes. The product would be flowing in the annular space between the innermost and the outermost tubes. So this configuration is especially suited for high viscosity products where flow behavior and the heat transfer become more challenging. The main advantage is that the heating or the cooling media, depending on the application, can act on the product from both sides. That means from the inner as well as the outer circuits. So in that way, we can ensure a uniform heat transfer efficiency, and in that way, we can avoid to have like thermal channeling within the product. Obviously, that is ideal for applications that are demanding some sort of gentle, even heating or cooling across the product stream. And finally, we have the quadruple tube. We can also mention the quadruple triple tube, as they all consist of 4 concentrical tubes. Similarly to the triple tube, the heating or the cooling media would be acting on the product from both the inner and the outer circuits. And in that way, we can ensure an efficient thermal exchange. So the key difference would be on the product channel design, because in the quadruple tube, the product would be flowing through the annular gap, which is connecting between the different tubular heat exchangers through tangential bends. And that is actually the key, because that tangential flow path that is specifically designed for those applications where we have particles could help to maintain the particle integrity. And for those applications where keeping the particle integrity is paramount, the quadruple tube could be the right solution. Now we move into the pilot plans on the service support. So we can offer access to our customers to our pilot plants. As we briefly mentioned before, we've got them located in Shanghai, China, Silkeborg in Denmark, and Dubai in Emirates. And obviously those facilities would allow you guys, to test new ingredients, to do like recipe development. So you can try new formulations. You can make use of our experts that are working in those research and development centers. And it would be the perfect way, to validate process parameters before you decide to scale it up into industrial flow rates. So I would say that it would be great, the best way actually to accelerate time to market whilst minimizing the risk. In addition to that, I would highlight as well, our performance agreements. I mentioned that as well before, but we can really help you to do customers performance agreements, to protect the machinery during the life cycle of the equipment that we are delivering to you. And at the end of the day, those agreements are providing to our customers a lot of peace of mind. That is obviously the key feedback that our customers are mentioning about our performance agreements. So there is a lot of value on those solutions. And once again, those performance agreements, those service support, in order to maintain and to preserve the machinery could be tailored to whatever specific needs you might have. As we mentioned earlier, even though we've got many innovation centers worldwide, the three most relevant that you have to remember for UHT applications would be Silkeborg in Denmark, Dubai in Emirates, and Shanghai in China. Those locations are fully equipped with pilot testing. So you could do process development. We would be happy to collaborate with you in order to come up with the best recipe and to scale it up into industrial flow rates. Obviously these innovation centers are playing a key role, and they've been playing this key role since many years, helping our customers to develop, to validate, and to scale new products efficiently on the way to market. In this slide, we just simply show our value that obviously goes beyond the machinery itself, because from the research and development perspective all the way to manufacturing, and especially if we consider service and support all the way through, we can really provide a full life cycle partnership. Our aim is to help our customers from this starting phase of product development all the way to a long-term performance and maintenance of the solution. And I believe that is at the end of the day what is like setting SPX FLOW apart. Okay, so thank you all for your attention throughout the presentation. Now I'd like to open the floor for questions, whether if it's about technology or specific applications or anything that we've covered today. Feel free to ask. We're here to help clarify any details, and if possible to dive deeper into what matter most to you. All right. Okay. So now it's time for some questions and answers. It seems that we've got already some questions. The first one, it is from Dafer Nabil. And the first saying that if the inlet product temperature is higher than 4 degrees, can the system adjust the temperature to gain energy? Okay, Dafer, I believe this question is coming from the slide where we were explaining the generic schematic of a UHT tubular system, and we were explaining the closed water loop and how to gain energy. The response is yes. We are always, let's say, designing the tubular system for the specific conditions that our customers are telling us. If the customer is telling us that the temperature inlet is going to be 4 degrees, we will put that in our thermal profile, and we will design the system accordingly. But if for whatever reason the temperature inlet is, let's say, higher than those 4 degrees, the system still would be able to recover energy. Obviously, if the temperature is warmer, let's say 5 degrees, 6 degrees, 10 degrees, the system would recover energy, but it would recover a little bit less energy than if the temperature inlet is colder. Right, we've got more questions. We have another question that says if it looks like the tubes are protected by plexiglass on the images, but further than that, are the tubes integrated on an isolation box? Right. So yes, here there are like different ways of providing the insulation. You can, of course, you can opt for like a plexiglass type of solution, but there is not really like an insulation box as such. So if you want to have like a real insulation on the tubular heat exchangers, the recommendation would be to go for like mineral rock wool and then stainless steel cover. That is something that obviously you can do on I would say the most sensitive parts of the systems. So then, for example, that could be the final heating section, let's say the sterilization phase, holding section, and then also on the first part of the cooling. And obviously, there are different ways, obviously, to do the insulation on those, let's say, individual tubulars. My recommendation would be mineral rock wool with the stainless steel cover. Okay. Then we continue with more questions, and I have to say that thank you for your attention, and thank you for like sending the queries. That means that that you are engaged and that you've been following the presentation. So, what are the PLC brands that we manage? Yes, we are working with Siemens. We can also work with Allen Bradley, depending on, let's say, the geography that we play in. There are like typical standards. So yeah, Siemens and Allen Bradley, they are both okay. No problem with that. And there is another question saying, is there any performance follow-up integrated on the automation? For example, like CAP duration, follow-up, delta temperature. So yes, I mean, when we are performing the CAP, that's going to be monitored. So depending on if we are performing like an intermediate aseptic cleaning or like a full CAP at the end of the cycle, all of that is going to be monitored. All right. And yeah, I mean, with our automation package, we've got the possibility to get real-time information in terms of like the temperature profile that we have indicated in the system to have, and also if there are like discrepancies in terms of like the pressure drops. Obviously, for like the temperature profile and let's say the holding section, those parameters are key. Because those are, let's say, the parameters that we need in order to calculate B star value, let's say bacteriological effect, and also F0 value. So the total lethal integrated effect. So those parameters, you can track them in real time. And yeah, our automation package would give you the possibility to have that information in real time. Then here we've got more questions. What could be the limit on viscosity for sterilization? Talking about high viscous products. So the limit on viscosity is always like a tricky question, and actually that depends on the type of modular tubular that we are using. So during the presentation, we mentioned that in our portfolio, we have different models. We have the double tube, we have the triple tube, the quadruple tube, we have the multi-tube. So at the end of the day, the vast majority of the occasions, especially when we are working with low viscosity products, would be to use the multi-tube. The multi-tube, I would say the upper limit in terms of viscosity would be around 1,500 centipoise. For the high viscosity products, then probably we need to move to a different model. So we need to talk about an annular type, like a double, triple, quadruple tube. And if we move into those technologies, then the upper limit viscosity could be around 8,000 to 9,000 viscosities. So as you can see, it is like very high viscosities that would require like a special design of tubular, but that can be done. And then there is another question saying, what about high protein products? What could be the limit on protein? So, right, so for the protein, if we consider, for example, standard milk, the protein content is around 3.5%. So that is already, let's say, a challenge in terms of like the fouling when you go through like the complete thermal profile in a UHT systems, because we know that proteins are quite prone to fouling, and then around 65 degrees, the proteins in the milk would start to denature. They will start to foul. So obviously, there should be like some sort of let's say proportion in which if you are increasing the protein content in your product, obviously you can expect to have more fouling. You can expect to have like shorter production runs. What we have done with some protein-enriched liquids or beverages, I think we have gone all the way from like 3.5 that you can find easily like in milk to 5.5, 8, 10%, 12%. But that is typically the limit on in terms of like those beverages enriched with protein. The limit, what is the limit? The limit would depend, let's say, on what is, let's say, appropriate for the customer in terms of like how much time the customer has to stop and perform CAP. So what is acceptable in terms of like the production run? You know that the higher the protein content, the shorter the production time, and because the fouling rate is going to be increased. So in terms of what we have done in the past, I can tell you that we have done enriched protein products up to 10-12%. All right. Let's see if there are more questions. Then we've got here how tubulars can help in particles product. Well, obviously the tubular is the best technology to process products containing particles, and that is essentially because we can play around quite easily with the diameters of the pipes. The important thing here is that when we are getting the request from our customers, we need to have conversations with you, and we need to understand what would be the particles expected in the product, how big those particles are, and the concentration of those particles. And then on top, we need to know if you want to preserve the particle integrity of those particles, because depending on that, we will have to decide to be using one type of, let's say, tubular or other. But just in generic terms, the tubular technology is probably the best one in terms of providing flexibility for customers that are running that type of application. Yeah, it's important to know the maximum particle size, concentration, and if it's important, the particle integrity for the customer or not. So we've got here another question. What maximum viscosity, say 3,000 Pascal, can be processed? Here, when we talk about viscosity, typically we talk about millipascal seconds. That is the equivalent to centipoise. As I was explaining to a previous question, typically for a multi-tube, that would be the tubular technology that we would be using for lower viscosity applications or low to medium. The maximum viscosity would be around 1,200, 1,500 centipoise. If the viscosity is higher than that, maybe we need to move into an annular type. And then we would be able to go with 3,000 millipascal seconds or 3,000 centipoise. If the viscosity is greater than that, let's say greater than 8,000, 10,000 centipoise, we would need to move into a scrape surface heat exchanger, which is a different technology. It is also a technology that SPX FLOW can provide. We can design scrape surface heat exchangers, and we can help you with that. So typically, when we are getting the inquiry from the customer, we have to assess. Well, we have to assess many things, but in between those things, the two key parameters is like the viscosity and the particle size and concentration. With those two variables, we can do a quick screening in terms of the most suitable technology. Within SPX FLOW, we are fortunate because we have the three main heat exchange technologies: plates, tubulars, and scrapes. And we can do that quick assessment to see if we should be offering a plate, if we should be offering a tubular heat exchanger, or a scrape surface heat exchangers. And obviously, we need to go deeper into like those details from the customer. What is the actual viscosity, how you have measured that viscosity, what sort of equipment you have used it, and then the presence of particles. Okay, and then when we have all that information and when we are ready, let's say, to do the first thermal calculations, we would be able to tell you if we consider that the most suitable technology is going to be a plate, a tubular, or a scrape. Okay, yes, so we've got here another question. I always see upstream application after section 1. Enter the homogenizer. It's not better downstream after section during cooling with using aseptic homogenizer. Well, here there are like different ways to work with this. Typically, what we are doing as a standard solution for our customer, when we are quoting for indirect technology, so that means plates, tubulars, and scrapes, we are typically working with upstream homogenization. That means that we are locating the homogenizer, which is non-aseptic, when we are heating the product. Basically, we are typically position the homogenizer at the temperatures of about 65 to 75. And we are also typically providing that homogenization step in combination with a degasser. You know that typically in the degasser, you are like losing some degrees, and then you are recovering those degrees on the homogenizer. What we are typically doing on direct technologies is that we are typically working with the homogenization in the downstream phase. That means that we are using a hygienic homogenizer. And why is that? Because typically when we are considering, for example, an infusion system or like an injection system, in the final step of the sterilization, when we are heating those 145, 150 degrees, when you are like increasing the product to those temperatures, there is typically like accumulation of fat. There could be also like a flocculation of proteins. So essentially the products could have like small lumps of fat micelles and protein agglomerations. So you then do like a downstream homogenization in order to homogenize the product and try to get rid of those. Having said that, there are also customers that are working both in direct technologies and indirect technologies, and they can decide if we should be working with a homogenizer that can work both upstream and downstream. So as you can see, everything is possible. Typically in indirect technologies, we work in upstream. With direct technologies, we work with the aseptic technologies. Sorry, I'm getting. So we've got another question, and I think that's going to be like the last question because we are running out of time. And it says, in tubular UHT, is it possible to cool the fruit pulp after heat treatment up to -2 degrees Celsius? So, to be honest, I have never seen an application for a tubular UHT systems where we are cooling that to that temperature. Typically, if we are talking about a UHT system, typically the temperature for like fruit is not that that low, and typically for fruit, as it is a high acid product, typically you don't have to even do like a UHT treatment. Obviously, depending on the fruit, depending on the product, depending on the physical properties, you can do different types of heat treatments. But typically with fruit, you are doing more like a pasteurization type of treatment rather than a complete UHT or like commercial sterilization. Okay. All right, gents. Thanks a lot for your attention. Thanks a lot for your questions. I can see that we've got more questions, and I will work with the team to give you like an answer of those. But we have run out of time, so we need to close the webinar. Thanks a lot, and you have a great day.